Hi guys, we are going to talk about the mole today. And you've read in your book, you may have watched the other video, and the mole can be kind of a confusing topic, but you've already been introduced to it with the lab that several of you have done already. The mole is a counting unit that we use in chemistry. And you guys are familiar with counting units. There are several of them that you are already familiar with. One of them is dozen. If we have a dozen, that means that we have 12. Now we can have a dozen eggs or a dozen roses or a dozen pieces of corn, and it doesn't matter what the item is. We know that we have 12 of them no matter what. Same thing if we're talking about a pair. A pair means two. So if I have a pair of mittens, I've got 2 mittens. If I've got a pair of dogs, I've got 2 dogs. Okay? So counting units help us when we're talking about a specific number of things. And the mole is the same. If we have 1 mole of something, and the abbreviation you're going to see for mole is MOL, if we have 1 mole, we have 6.02 times 10 to the 23rd, no matter what it is. If we're talking about atoms or molecules or paper clips or anything, okay, 6.02 times 10 to the 23rd. So that's the number that is equal to 1 mole. Knowing that, we can do some calculations. And this is some of the stuff that you're going to find on your practice problem sheet, where we're going to use the information that 1 mole is 6.02 times 10 to the 23rd, which you know is also Avogadro's number. That's the label for it. We can use that information to do different conversions. So here, we're going to start with 6.4 moles of copper, and we want to know how many atoms that is. So I'm going to set up a dimensional analysis problem just like we did way back in chapter 2. Okay? I've got 6.4 moles of copper as my starting information, and now I'm going to use a conversion to figure out my answer. Okay, I want to end up in atoms of copper, and moles of copper is what we already have, so that goes on the bottom. So now, knowing Avogadro's number and knowing what a mole is, I know that in 1 mole of copper, I have 6.02 times 10 to the 23rd. Okay? So, dimensional analysis works because we can cancel out moles of copper and moles of copper. We're left with atoms of copper. So now I need my calculator. And we already talked in class about how to do this with a calculator, so it works. So with my TI 84 Plus, I'm going to type in 6.4 times 6.02 EE23, and my tells me 3.8528 E24. Okay? Now you all know that that is not the final answer because first of all, I haven't looked at sig figs, and second of all, we already said this E isn't part of a real number, it's just calculator talk. So, I'm going to look back at my beginning information, and I had 2 sig figs, which means my answer will have 2 sig figs. So I have 3.9. Now my E tells me times 10, and whatever number is after your E is your exponent. So the answer here is 3.9 times 10 to the 24 atoms of copper. Make sure that you label all your problems. Okay, so that's one problem we can do. Alright, with that same information, 1 mole equals 6.02 times 10 to the 23rd of whatever it is we're talking about. We can do problems where we start with a number of molecules or atoms and end up in moles, like we're going to do here. So the information we're given from the problem is that we are starting with 7.27 times 10 to the 24th molecules of potassium hydroxide. Okay? I need to figure out how many moles that is. So in my conversion, I'm going to put 1 mole of potassium hydroxide on top, and just like 1 dozen roses and 1 dozen eggs both have 12 of the item in there. If we have 1 mole of molecules, it's the same as 1 mole of atoms. So I still have 6.02 times 10 to the 23rd. This time it's molecules, potassium hydroxide. Okay? Now, dimensional analysis rules again mean that it's going to work because molecules, potassium hydroxide is on the top and then it's also on the bottom, so I can cancel it out. Now, with a number on top and a number on bottom, when I get my calculator out, I'm going to be dividing this time. So I'm going to type in 7.27 EE24 divided by 6.02 EE23, and my calculator then spits out 12.07641196. Again, not the final answer because we haven't looked at sig figs and I didn't put a label on. Now our original number had 3 sig figs, so my final answer needs to have the same. So I'm going to have 12.1 and my label is moles of potassium hydroxide. So there you are. Those are the 2 problems where we're going to use Avogadro's number of 6.02 times 10 to the 23rd, which is the number of items we have in 1 mole of anything. Okay, we've done switching from moles to particles and then from particles to moles. Those are the kinds of problems you'll find on your practice problem sheet when you get to class, and let me know if you have any questions. Bye.